Hi, my name is Pavel Amelin. I'm postgraduate student from Belgrade State Technological University, named after Vladimir and I present the scientific report named Rational Design of Composite Stretching of Reinforced Concrete Elements for Experimental Research. In recent years, due to the increase in design loads in operated buildings, there is a need to strengthen their load-bearing structures. The use of high modulus composite materials contributed to the further development of reinforcement methods. The analysis of the works related to the composite reinforcement of reinforced concrete bendable structures showed the need for experiments with a variation in the ratio of the length of the composite reinforcement to the calculated length of the element. To solve this problem, it is necessary to design and calculate the composite reinforcement of bent reinforced concrete structures. Reinforced concrete beams made of heavy concrete of class B15 were selected as control samples. The geometric dimensions of the cross-sections of the prototypes, the classes of concrete and reinforcement, the configuration and diameters of the reinforcement rods were adopted on the basis of preliminary calculations, taking into account the prevention of destruction along inclined sections or due to the loss of overall stability. The reinforcement scheme of the samples is shown in Figure 1. The characteristics of materials required for calculation for the first group of limit states are shown in this table. For the experiment, we will take a calculated scheme of loading in the beam in the form of 4-point band with a projection of long projection of an inclined section equal to 4000 millimeters. For this article, we determine the bearing capacity and strength of the inclined cross-section for the usual samples under study according to equations. A unidirectional woven strip of carbon fiber C-cover-up 513 is used as reinforcement which is glued in a stretched zone 120 mm wide in one layer. The C-cover-up 513 tape has the following physical and mechanical characteristics: strength, modulus of Young, estimated tape thickness, and the cross-sectional area of the tape, as you see in this slide. The actual value of the load-bearing capacity of the reinforcement beam section is determined by the equation in the middle of the slide. The increase in the bearing capacity of the cross-section of the element is achieved mainly by increasing the height of the compressed zone of the element from the use of composite reinforcement. Based on the results obtained on the basis of preliminary calculation on the reinforcement of reinforced concrete bendable elements, as well as in order to rationalize the use of composite reinforcement, the authors has developed an experiment program in accordance with which the destruction of 4 series of bendable elements and auxiliary samples to them is envisaged. Firstly, testing of auxiliary concrete samples of the design class for compressive strength B13 in the form of cubes with a size of 10 centimeters based on the results obtained on the basis of preliminary calculation on the reinforcement and reinforced concrete bendable elements, as well as in order to rationalize the use of composite reinforcement, the author has developed an experimental program in accordance with which the destruction of 4 series of bendable elements and auxiliary samples to them is envisaged. Firstly is testing of auxiliary concrete samples of the design class for compressive strength B15 in the forms of cubes and prisms for compression, bending, determination of the initial modulus of elasticity. Second is testing of auxiliary samples in the form of reinforcement bars and unidirectional woven strips of carbon fiber C cover-up for longitudinal stretching. The next is testing of control samples of reinforced concrete elements with a short-time static bending load. It is series first. The next is static bending test of reinforced concrete elements previously damaged under the influence of an aggressive environment, unloaded and reinforced with carbon fiber canvases. It is series second, third and fourth. The ratio of the length of the reinforcement section to the calculated length of the element was chosen as the variable parameters during the test, as well as the angle of implementation of the traverse composite reinforcement alpha. The traverse composite reinforcement in the element while stretching the inclined section of the element has the function of adhering carbon tapes in the stretched zone to concrete. The calculation made by the authors was carried out with the aim of rational use of compositive materials when performing experimental studies on stretching reinforced concrete bendable elements. The values of the destructive moments allowed us to plot the effective operation of the composite material along the length of the element, variation of the angle of inclination of the traverse composite reinforcement to the longitudinal axis of the element with allow to obtain extensive data on the work of reinforced concrete elements of bending. Thank you for your attention.